There's one last sort of problem in this section that I want to take a look at. So far, we sort of worked our way up to proving trig identities, but we were just proving that they were true. In this sort of problem, we're actually going to use a trig identity. Now, this is something that you're not going to see a whole lot of next semester in first semester calculus, but those of you who go on to 3B, which is second semester calculus, you're going to be seeing a lot of this. So we're given this expression that involves a square root, and it's in terms of the variable x. And then we're told, let's suppose that x is 2 sine theta. So that's a relationship between the variable in the original problem and a new variable, theta. And we're being told that theta is between 0 and pi over 2. So that's putting us in quadrant 1. Okay. All of that's going to be given. Now, by the time you're in 3B, all of that won't be given. But right now, all of this is given. You've got that expression, you're told the relationship between x and theta, and you're told that theta is an angle in quadrant 1. And then what we're supposed to do is we're supposed to take this and we're supposed to write it in terms of theta and simplify. Okay, so I'm going to say the square root of 4 minus x squared. Now that's something that as is I couldn't simplify because square roots do not distribute over subtraction. But when I write it in terms of theta, I'm going to be able to simplify it. So let's see what happens. This becomes 4 minus, I'm going to replace x with 2 sine theta. So x squared becomes 2 sine theta, quantity squared. And of course, I would square the 2 and the sine theta. So that becomes 2 squared is 4, and then I get sine squared theta. Okay. Now there's a 4 in both terms, so I'm going to factor that out. So I'm going to say that's the square root of 4 times 1 minus sine squared theta. I see a 1 and a trig function squared. I'm thinking Pythagorean identity. And that's actually just a rearrangement of the basic one. If sine squared plus cosine squared equals 1, you write that off to the side. That means that cosine squared is 1 minus sine squared. And if you're comfortable seeing that without writing out this side work, that's fine. But notice now I can say that's the square root of 4 times cosine squared theta. So now, instead of having a subtraction problem under the radical, I have a multiplication problem under the radical. And square roots do distribute over multiplication problems. So that's the square root of 4 times the square root of cosine squared theta. Now the square root of 4 is 2. Be very careful here because you have a picky teacher. The square root of cosine squared is the absolute value of cosine of theta. Okay. Because cosine is sometimes positive and sometimes negative, but square roots are never negative. Now I can use the fact that I was told theta is in quadrant 1. So now I know cosine of theta must be positive, so the absolute value isn't doing anything. So I can say, but I've got to justify it, I can say theta is in quadrant 1, so cosine of theta is bigger than 0. I'm actually fine if you just tell me theta is in quadrant 1. That's enough to drop that absolute value because you're actually evaluating it. You're saying, if theta is in quadrant 1, cosine theta is positive, taking the absolute value of something positive doesn't do anything to it. Okay. Now, to get full credit on a question like this, I need to see the absolute value, and I need to see the reason it disappears. It's entirely possible that some of you would look at this and you would say, but I'm in quadrant 1, so cosine is positive, so the square root of cosine squared is the absolute value, which is just cosine. You could think through that without writing it and go right to here. But I can't tell the difference between somebody who mentally thinks through these steps and somebody who carelessly says, the square root of cosine squared, that's just cosine, which is not always true. I'm not a mind reader, and I'm not a very trusting person. So you don't get the benefit of the doubt. If you don't show me that you thought through those steps by writing the absolute value and writing the reason that it evaluates to being just cosine of theta, then you're going to lose some points. Okay. Even if you have the right answer. So do be very careful about that because as you're checking your answers in the back of the book, doing the odd-numbered problems, you can get a false sense of confidence because you're getting things right, but you're not fully justifying the steps. So super, super important. This haunts my students all through 3 semesters of calculus. They forget that the square root of something squared is the absolute value of that thing. And sometimes it doesn't make a difference, but often it does. So I look for it every single time. Okay, excellent. I'm going to have you folks try one of these. And I've picked one of the assigned homework problems. So again, you're getting a jump start on the homework by working this one out. So here we're going to have the square root of x squared plus 25. You're going to let x be 5 tangent of theta. And theta is going to again be between 0 and pi over 2. So again, an angle that's in quadrant 1. So same directions. I want you to take this expression, write it in terms of theta, and simplify your answer.